Look, this stuff about finch beaks is certainly interesting. Let's not confuse ourselves about that. The question is, can it be extrapolated, or does it represent cyclic variation? I can say, here's an account of how the eagle flies. Look, I get up, I jump in the air, I flap my hands a couple of times, and I land a few feet from where I started. Thus the origin of flight. Now, the obvious response is, this is nutty. You can flap your hands as long as you want. You won't fly like an eagle. The argument from extrapolation can work in some circumstances. It fails in other circumstances. Plainly, in the case of a human being who jumps 2 feet in the air and then lands 2 feet from where he started, the argument from extrapolation fails. What persuades you in the case of the Galapagos finch that what seem to be cyclic variations are the start, the commencement of a grand process of speciation? That's a step in the argument that has to be completed. It's not enough to say, well, it's more of the same. It's not more of the same self-evidently. It can easily be bounded variation of exactly the same sort as we see in any species experiment. Now, the contrary may be true. We may be seeing the development of entirely new species. The Galapagos finch starts off as a finch, and within 100 million years there'll be a Galapagos elephant. Could be. But we need a whole lot more by way of evidence than a couple of nutty journalists going down there looking at finch beaks and writing a Pulitzer Prize-winning book. A whole lot more of this is to be serious science. I mean, this doesn't even pass the threshold of anecdote. Finch beaks change in size. Yeah, they do. They change in shape, too. It seems to be correlated with seasons. There seems to be a regress back toward the mean when the seasons change again. If this is the part of a spectacular evolutionary extrapolation, let's have additional reasons for thinking that. Otherwise, we're not even talking about a scientific hypothesis.